Now we will move on to the second objective, that is to disprove conjectures using counterexamples. Here, let us learn about counterexamples now. So imagine a statement that is, if a food is fruit, then it is apple. Just by reading this, I'm sure you must have known this is false. It's not a true statement. But a statement or conjecture can be false. You can make any statement as long as it can be proved true. As long it is remaining true, it is a conjecture. But if you disprove it, it's false. You can dissolve it in the sense. Now this is a statement which says any food is a fruit, then it must be apple. Wait, this is the condition, this is the conclusion. Let's see for a counter example some other fruit than apple. Say mango. It is not apple. Mango is another fruit, but it is not apple. So this condition is true, but the conclusion is false. Then what we come to know is mango is the counter example to disprove this statement. So mango is a fruit, but not an apple. So this statement is disproved. This particular example which is used to disprove the statement is the counter example. Now we will solve more problems. It will be more clear. Say for example, counter example. Now a conjecture. Let's think about conjectures or statements. A conjecture is true for all cases, but you must prove it. So only one example, if one example disproves it, then it is that's gone. The conjecture is false. So any example that contradicts the conjecture is a counterexample. So counterexample is like countering or tackling a particular statement. Counterexample can be a number, figure, drawing, or statement. So now we will solve some problems on counterexamples. Here we have find counterexample to show that each conjecture is false. So if n is a real number, then minus n is a negative number. So real numbers are any numbers which are real, basically not imaginary numbers and real numbers. Imaginary numbers means the numbers with I, which you will be learning in more detail in the future classes. But now, real number would be any number that is, say, 2, 4, minus 3, or anything, that is which can be counted. Now, here we will first analyze the statement and then take some examples. So n over here, if minus n, it must be negative, right? So let's take example 4. When you multiply minus sign to it, what's the answer? It's negative 4. Yes, it's a negative number. Let's take 37, or you can take any example which comes to your mind. Multiplied by minus sign. Yes, this is minus 37, which is negative as well. But now look over here. If I have taken a negative number itself, minus 2, multiply with minus sign, and what are you going to get? Positive number. Now this over here is a counter example because this contradicts the statement or the conjecture. So the counter example that contradicts the conjecture is this minus 2. Or you can take any negative number, because when n is negative, minus n would be positive. So this is the counter example for this particular conjecture. So it can be any negative number. It can minus 2, minus 5, minus 10, or so on. Any minus number. So when you multiply minus and minus, it becomes positive, and this statement is proven to be false. So that's the counterexample. Similarly, let's solve over here. Find a counterexample to show that each conjecture is the same continuation. Over here we have ABC is congruent to DBE. It's very hard without a diagram over here. Now we can see B is a common angle. Now they are saying vertical angles. So let's just draw vertical angles initially. So let me take B as the common angle and AB over there, and this is C, and D, B, and E. So now what it says is ABC, this angle is congruent to this angle. So that means They must be vertical angles. Yes, in this case it's true. Why? Because we have studied vertical angles means two straight lines. Okay? Two straight lines, whenever they cross each other and the joining point over here, the opposite angles will be are called vertical angles or vertically opposite angles, and they are always congruent, they're equal. So if this is 60 and this will also be 60. Yes, but now can we disprove this? Yes, we can disprove this, because you can have the same angles but not vertically opposite. Say for example over here, you can see ABC over here, this angle and this angle are equal, DBE. Say this is 30 and this is 30. But they are not vertically opposite. If they are vertically opposite, they must be straight like this. Over here, when ABD are non-collinear points, non-collinear, and ABC are non-collinear. See, they're not in the same line over here. Sorry, I removed this. When ABE was collinear and the points were on the same line and this on the same line, then they were vertical angles, right? But now if you just tilt this line, it's not vertical anymore. So this is a counterexample. This particular figure is the counterexample. So this is how we can easily disprove this particular conjecture. Now that is about counterexamples. Similar situations may come. Just try to analyze more examples. Say this is a simple diagram. Try to write. See the statement, write it out, and then find more examples disproving it. You will get plenty of examples. I can draw so many different figures which can disprove the statement. Any one is enough. If this comes as options, it's very easy, but otherwise you need to think hard and try to get this. Counterexample disproves a conjecture. I hope this is clear. If you have any doubts, any questions, do type them down in the chat, in the comment section. I will try to get back to you as soon as possible. And stay tuned for the coming videos. And if you have found this useful, if you have learned anything from this, do subscribe my channel. It would be a great help for me and I would greatly appreciate it. All the best, dear students, and happy learning.